Welcome to this video about risks to good soil water processes and soil disruptors. I will tell you about how and why soil water processes may not always function the way humans expect. This slide shows the hydrological cycle, which describes the movement and storage of water between the air, the soil, the plants and the open water. The amount of water remains more or less the same over time, but where that water is depends on a wide range of factors, most of them related to the climate in a particular location. The water cycle is important for ecosystems, life, and certainly as human beings, and soils have an essential role in it. Soils store and filter water, and healthy soils are very important to transport water by infiltration, redistribution, percolation and drainage, to ensure plants can have enough water and air to sustain ecosystems and food production. You can imagine, soil water processes and soil functions have a strong link with climate. A dry climate with little rain results in a desert where no or only few plants can grow. There, life is hard for people as well. On the other hand, in a wet climate, extreme amounts of rainfall may cause the soil to be so full of water it will start to overflow and can then form a mud stream, as you can see here. Soil water processes can be disrupted by nature, for example if the climate is too dry or too wet. But soil water processes can also be disrupted by how we humans manage the land. So what kind of natural and human-induced things disturb these soil water processes? Well, let me tell you. First of all, there is loss of soil wettability, which can happen due to soil crusting or the development of soil water repellency. You'll hear more about this another time, but here's a quick overview. Soil crusting is the formation of a thin layer of dense soil. Soil crusts often look like a platy structure, such as in this picture. Soil crusts often form by the impact of raindrops falling on the soil. There are also biological crusts, formed by, for example, bacteria. Soil crusts make it more difficult for water to enter and wet the soil. Soil water repellency is when the soil will not accept water because waxy coatings have built up, kind of like a raincoat. It develops due to the many organic organisms and substances that are in and on the soil. Water repellency can develop in both cultivated soils and after fires, which along with burning things cause organic substances to melt and coat the soil. If you would put a drop of water on a water-repellent soil, it will simply stay on top of the soil. Another soil water process disruptor is soil compaction, which can happen when certain soils are put under pressure, like here by a tractor that is used to work on the land. Soil crusting, soil water repellency and soil compaction reduce soil function and lead to two things. First, rainwater and irrigation cannot infiltrate easily anymore. This leads to ponding of water on the surface when the land is flat, or to increased runoff when the soil is on a slope. Second, when water can't get in, it will be harder for plants to grow, which leads to poor quality vegetation and even to bare soil. What other kinds of things can happen when soil water processes are disrupted? Well, if the soil is no longer protected by plants because they cannot root there, the wind can take massive amounts of soil with it. In, for example, Iceland, the erosion of wind is much bigger than the erosion by water. Here you can see a dust storm where vegetation has disappeared, while in the front of the picture the vegetation still protects the soil from erosion. And if water cannot properly infiltrate in the soil, it may lead to erosion by water. Here you can see the result of water erosion. A deep gully has formed on the land otherwise used for grazing. If nothing is done to prevent further erosion, the gully will become larger and larger, while less land for grazing will remain. Erosion can become so bad it removes all fertile soil and the barren landscape is left behind. Plants not growing and water not infiltrating will have a further effect. Plants normally intercept rainwater when it falls, and soils filter and store that water. But if this is no longer possible, a tremendous amount of the water from a rainstorm will run off as soon as it has fallen on the ground. With large rainstorms, increased runoff can lead to floods. Floods may occur especially in hilly areas, as all water collects at the lowest point in the landscape, which is where the river flows. Often towns and cities are located near these rivers, and they get flooded as well. One of the disruptors I have not told you about yet is soil sealing. Soil sealing can be caused by natural causes as well, such as the lava flow you see here, or by humans covering the soil with pavement and buildings. With soil sealing, water cannot infiltrate at all and simply collects on the surface or runs off. Because the soil is covered, it will not be eroded by wind or water, but all the water that cannot infiltrate can become a problem. And unless it is consciously collected, it is not available for plants or we humans. As you have seen, soil water processes may be disrupted by various natural and human-induced causes. As a result of the growing population, the soil degradation caused by human impacts has increased as well. Notwithstanding the large global land area affected by soil degradation, there are a lot of soil management options that can help to save and restore the soil function and ensure soil water processes function properly again. The good news is that we can learn about these soil water process disruptors and troublemakers, both the natural ones and the ones we humans are responsible for. And there are sustainable soil management actions we can take to prevent and correct them, and their associated problems. If we all do this, our soil can continue to function well and support life for many generations to come. The take-home messages of this video are: soil water processes can be disrupted by natural causes and by how we humans manage the land. Soil water processes can and need to be sustainably managed to provide the life-supporting services we all depend on. We can learn about soil disruptors and the sustainable soil management actions that can prevent and correct them. Thanks for watching and taking care of the soil and water right under your feet.